Okay, welcome to another video for O-level math students. This is paper 1 statistics, the things that you need to know when you are doing your paper 1, and statistics often comes up in paper 1, can also come up in paper 2 because there are lots of things to test in statistics. So let's see what we have here, and I'll be doing a range of questions explaining to you in the process what is what, and then we can see. The students in a school each choose a piece of fruit to eat with their lunch. They can choose from either an apple, a banana, or an orange. On Monday, Claudia records the fruit chosen by 30 of her classmates. So this 30 is important for later on. Why is it important? Because it's going to tell me that my frequency should add up to 30 at the end. So that's what I should be aware of. So it says complete the frequency table. So whenever you're counting things like that, it's best to sort of cancel out the ones that you've counted so that you don't forget what you've counted and what you've not counted. So 1 2 3 4 5 6 7 8 9 10. Okay, so that's 10. Then for bananas, 1 2 3 4 5 6 7 and 8. So that means the other should be 12 because you have to add up to 30. Let's count 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so that's that. Then it says on the grid, draw a bar chart to show this data. So whenever you are doing this, remember that the bars have to be separated. So the first bar has to go up to 10. So I'm going to take my ruler and my pencil and draw this. Make sure that you draw it with the ruler and a pencil. Don't draw wavy lines. Sometimes the examiner will give you a penalty of a mark. So that's 10. I'm going to write inside it. This is the bar for apples. So I can write a small apples here. Then or beneath it as well, you can write it like that as well. It's your choice. Banana is 8, so that goes banana. Eight. So bananas, let's just write down B, and orange is 12, so there goes orange. Remember that in a bar chart, bars are separated. In a histogram, they are together. So that's oranges. I'm going to write oranges, bananas. You can shade if you want. That's optional. As long as your bars are visible to me, that should be it. So continuing this question, it says on Tuesday records the fruit number by random sample of 30 students. So that was the graph for Monday, I think. Yeah. And this one is for Tuesday. It says his results are shown in the table below. Use Ahmed's results to estimate the probability that the student selected at random chooses an orange. So out of 30, how many choose an orange? 7 choose an orange. So my probability will be 7 out of 30. That's plain and simple. There's a total of 180 students in the school. Use Ahmed's result to estimate. So what I can then say is that this can either be done through relative frequency, or you can simply use ratios. You can see I choose an apple on Tuesday. So I'm going to say that apple to total. So 8 people choose apple out of a total of 30. But let's say if you have 150, what happens then? If I write an x, I can then cross multiply 30x equals to 8 into 150. Don't multiply, this will automatically, something will cancel out and you can get your right answer. So 3 times 1, 3 times 5, so 5 times 8 is 40. That's simple. Moving on. The height of water in centimeters in a river is recorded every week for 10 weeks. The height of the water compared with its normal levels are listed below. Work out the range. So the range is the highest value minus the lowest value. So what's the highest? I can see that 40 is the highest. The lowest is minus 45. So that gives me a total of 85. And it says calculate the mean. It's for 2 marks. That means what I have to do is mean is basically sum of numbers over number of numbers, or you can just right? Sum over n. So what's the sum? Let's start calculating. That's minus 75. Add up minus 30 to it. So that gives me a minus 110. Minus 70 and say minus 30 is minus 100. Okay. Then it starts minus 105. Minus 115. Another minus 10. Minus 135. Then I add 40 to it. So if I add 40 to it, I get 95. 35 and then 5 separately. Minus 95, sorry, minus 95. Okay, then I get minus 75 and then minus 50. So that gives me minus 50 divided by 10. That's minus 5. Okay. I hope I've added them correctly. Let me just verify my calculations. That was minus 80, minus 100, and minus 140, and then 50 and 40 is 90. So 50, yeah. My calculations are correct. Okay. Let's look at this one. It says the table shows the results when a dice is thrown 300 times. Relative frequency. Now, relative frequency was added to your syllabus in 2018. That's when you start seeing the questions. Of throwing a 4 is 0.2. Relative frequency works in pretty much the same way that probability does. So, it says of throwing a 4. So, throwing a 4 is P out of a total of 300 times. So, I can say that P over 300 should equal 0.2. I can just multiply this 0.2 into 300 and that should give me 60. Then it says find the value of Q. So let's think about the value of Q. I know that this came out as 60. Now that was thrown a total of 300 times. So I can say that all of this must add up to 300. Let's add them up. 55. What's easy to add? 45 is easy to add. So what do I get? I get 90 and 100. Then 50 is easy to add. So plus 50 gives me 150. Then 60 is easy to add. So that gives me 210. 210 plus 42. So that gives me 252. 300 minus 252 is therefore 48. You see, you can work with the pencil, cancel out on the diagram as well. It doesn't matter. It's your working. You can do whatever you want. You can calculate the way that I did. I jumbled around the numbers and then sort of went with my calculations. So how many times would you expect to throw a 2 when this dice is thrown? 1,000 times. So when it was thrown 300 times, so let's write down total. Success. Let's call that a success. You were successful 42 times. How many times would you be successful if you threw it 1,000 times? Again, a question on ratios, or you can also use relative frequency. It means the same thing. 300x equals to 42,000 basically, 42,000. So 42,000 divided by 300, what do we get? 3 times 1, 3 times 4, 140. Okay. Then this is a question on cumulative frequency. It says the temperatures in degrees centigrade of 120 people were measured. The results are summarized in the cumulative frequency diagram. Use the diagram to find an estimate of the 20th percentile. Now, if you know the 20th percentile is basically the 20% of the data set. So 20 over 100 multiplied by 120. Let the zeros cancel out. 24. So I'm going to read 24 from my graph. 24th person. So there are 10 boxes. The length of this box is 20. So there are 10 boxes. Each box is 2 units. So I'm going to go like that. Remember that on the exam you have to do this with a pencil, and make sure that you draw these vertical and horizontal lines on your diagram. Let the examiner see that that's your working, because sometimes that will be the mark for the working that you will be given. So that gives me 36.6. That's very precise, and that's my correct answer. Then says the number of people with a temperature between 36.8 and 37. So let's start reading from 36.8. Coming up approximately here. So that should be 2 plus 2, 64. 36.8 and 37. 100. So that gives me 100 minus 64 is 36. That is my correct answer. Then you have a question on a histogram. It says the time taken by each of the members was recorded. Some of the results were summarized and illustrated in the diagram. So there's a partially drawn histogram for me. Use the histogram to find the value of P. So I have to find this value of P. Now remember that when you're drawing histograms, you plot frequency density on the vertical axis. Frequency density is basically frequency divided by class width. What is class width? First of all, you need to see if these classes are connected. Most questions on your O-level math exam will have these classes connected. Class width is basically the upper boundary minus the lower boundary. So 2 minus 1 gives me 1. 3 minus 2 gives me 1. 4 minus 3 gives me 1. 6 minus 4 gives me 2. So I can have different class widths for different classes. So let's see. I want to find the value of P. Do I know its frequency density? Let's check. This is the class that I'm talking about. 4 to 6. I know its frequency density. I'm going to say that its frequency density is basically 8. So what can I then say? I can just apply my formula and say that 8 equals to P over 2. P is therefore equals to 16. What is the other way of thinking about it? Remember that on a histogram, the area of the bar is equals to the frequency. You could have also done that. So area of the bar indicates frequency. 8 into 2 then gives me 16 as well. So that's 16. I can move this working here just to show the examiner that that's what I've done. Complete the histogram. So there are two bars missing. One is a bar that is from 1 to 2. I will need its frequency density. So that's 6 divided by 1. That's also 6. So I'm going to draw a bar here from 1 to 2. That's 6 units. And I'm going to draw another bar from 6 to 8. Its frequency density should be 4 divided by 2, and that's 2 again. So I'm going to draw a small bar. I'm going to say that this is the bar that I need. Okay, I can shade them. All other bars are already drawn for you. Okay, then another question says, Adil observed that the number of people in each of 20 cars entering a car park. The results are shown in the bar chart below. So that's a bar chart. That's okay. It has spaces. Write down the mode. So mode is the most frequent observation. What was your most frequent observation? That a lot of people had exactly 2 cars. So your mode is therefore 2. Calculate the mean number of people in each car. So for the mean, I need total people divided by total cars, or sum divided by n. So I know that there are 30 cars. So my denominator is clear to me. There are 30 cars. Let's 20 cars. Sorry, 20 cars. 20 cars. Let's find out how many people are there. So this means there were 2 cars, each with one person. So I'm going to say that 2 into 1. There were 7 cars with 2 people each. So that's 7 into 2. That's 14. There were 6 cars with 3 people each. So 3 into 6 gives me 18. 4 cars with 4 people each. So 4 into 4 gives me 16. 5 and 1. So 5 and 1 is 5. So I'm going to add up all of these numbers. I'm going to say that this is basically 2 plus 14 plus 18 plus 16 plus 5. Okay, yeah, I think that's it. Let's add them up. These two gives me 30 and 50. Just a moment. Okay, 20 and 30 give me 50, so that's 55. So 55 divided by 20. So I can either go on and write this as a decimal number, that's absolutely fine, 11 over 4, or I can write 2.75 if I know my calculations quickly, so that's 2.75. I think that should be the correct answer, unless I've done a calculation mistake, which I don't think I have. Okay, moving on. The number of emails received by 18 students in a class one Monday are given below. Complete the frequency table for these emails. So you see what I have is classes. So I need to classify all of these into classes. This column is left empty for tally marks. I hope everybody understands what tally marks are. When you see a number, let's say you see 4, you know what category it falls into. It falls into the first category, so you write it there. 12 falls into the third category, 14 falls into the third category, 6 falls into the second category, 3 falls into the first, 6 falls into the second, 9 falls into the second as well, 7 falls into the second as well, 11 falls into the third category, 8 falls into the second category. So you mark it like that. That indicates a total of 5 observations in that category. 7 then also falls into this category, 11 also falls into this category, 14 is here, 6 is here, 13 is here, 5 is here, 12 is here, 9 is here. So the frequencies are as follows: 3, 8, and 7. That's the total of 18. Yeah, that's the correct answer. Then this is about probability. You can solve probability if you want. Let's talk about this question. It says a football team recorded the number of goals scored in each of their 20 games. The table shows the results. Write down the mode. So the mode is the most frequent observation. That one has the highest frequency, so the mode is 0. Now when you're calculating the median, what you need to do is find out where half of the frequency occurs. So what's the total number of frequency? That's 20. So you're going to say that half of 20 plus 1 th. The formula for the median position is half of n plus 1 th. So half of 20 plus 1 th. That gives me 10.5. So I'm going to look for the 10th and the 11th observations both and then add them together. So if I start counting my observations, there are 6 observations here, then 5 observations here. So that makes a total of 11 observations. I am looking for the 10th and 11th, so I can confidently say that they were both in this category. What were those observations? Each of those observations, so that the number of goals scored was 1. So I'm going to say that the 10th is also 1 and the 11th is also 1. So you take an average of that. 1 plus 1 divided by 2 is also 1. So that's 1 is your median. So the median number of goals scored is 1. Then it says in the football team, the 2 tallest players have a mean mass of 75. The 8 shortest players have a mean mass of 60. Calculate the mean mass of all 10 players. So remember that mean is basically sum over n. Now Since this is the mean mass, can I calculate the sum of these two tallest players? Can I say that 75 equals to sum divided by 2? Why? Because there were two players. So the sum would then be 150. So I get 150 from here, and then 60 into 8, 480. So 480 plus 150 divided by 10. That's 630 divided by 10. 63. So I added the sum of the individual ones, found the combined sum, and that gave me the mean of all 10 players. Then this is another question on a histogram. Let's see what we can do about this. Let's try to draw this quickly. It's 3 marks. Again, remember that I need the frequency density, and for frequency density I need the class width. So I'm going to calculate the class widths here. 20 minus 10 gives me 10, 25 minus 20 gives me 5, 30 minus 25 gives me 5 as well, 50 minus 30 gives me 20. So frequency density. Frequency divided by class width. 16 divided by 10 should give me 1.6. 15 divided by 5 should give me 3. 10 divided by 5 should give me 2. And 12 divided by 20. Okay, 12 divided by 20 is 0.6. Let's start drawing. I have to start drawing from 10. So I'm going to say that the first bar is between 10 and 20 and it needs to have a height of 1.6. So that's 1.6. Draw this with a ruler and a pencil. Don't draw wavy lines. The examiner will deduct marks if your histogram is not accurate. 20 to 25. It should have a height of 3. That's high. Alright, just give me a moment to sort out this. Then 25 to 30 is a height of 2. So that's what I'm going to draw. And then 30 to 50 is a height of 0.6. That's low. So you can shade them if you want. Okay, so that's my final answer. Okay, let's look at another question. I hope there wasn't a follow-up question. This says these are the minimum temperatures in degrees centigrade recorded by each day during 1 week. Find the range. So the range is again the highest minus the lowest. What is the highest temperature? All of these are in negative, so you need to see the smallest negative that's there, and that I think is 0.7, minus 0.7. What's the lowest? It's minus 4.6. So minus 0.7 plus 4.6, that gives me 3.9. How many of these temperatures are between minus 4 and minus 2? So minus 2 and minus 4. Now remember, the number line works like that, okay? Minus 4, minus 3, minus 2. So any number that gets plotted between minus 4 and minus 2, yes, 2.3 would get plotted there. Minus 4.6 would go out of range. Minus 1.2 would also go out of range. Minus 0.7 also. This also. This one is. And that one is. So there are three temperatures between minus 4 and minus 2. Then in a survey, 3 out of every 100 women were taller than 1.9. One of these 200 women is picked at random. Calculate the probability that she is not taller than 1.9. Okay, so that's sort of a relative frequency question. Okay, 3 out of every 100 women are taller than 1.9. So 97 are not. So not taller is just simply 97 out of 100. A new housing state is being planned. They've given you the relative frequencies. Okay, the survey was carried out to see which plan people preferred. The relative frequency table shows the results. 52 people preferred plan C. So plan C is 0.2. How do you calculate relative frequency? You take the frequency of that category and divide it by the total. So it says 52 people preferred plan C. How many people preferred plan A? So what I want is that I can just do it by saying that the relative frequency to the actual values. Let's make a sort of ratio. So relative frequency is 0.2. The actual people were 52. So if the relative frequency is zero point 0.3, that's for category A. How much is the actual value? Okay, so I'm going to say that 0.2x equals to 0.3 into 52. I can then sort of do a bit of calculation. Okay, so removing this decimal, 2 times 26. So what's 3 times 26? And that is 78. And it says calculate the total number of people. Now, you could do it in the same way. You could say that 0.2 into 52. And I want a total relative frequency of 1. It's like probability, it adds up to 1. Or you could just calculate C and add that up again. Calculate B and add that up again. And I think that's very clever of the examiner. It's this given you numbers that sort of add up to 0.5 together. So I could say that B should be equal to the relative B should be equal to the sum of A and C. You would also do it directly. So 0.2x equals to 52. Not that that's difficult. 52 over 0.2, 10, 2 times 1, 2 times 26. So that's 260. Okay, moving quickly to the next question then. Okay, this one is about a group of 60 students were taken, where each asked their favorite fruit. The results are shown in the table. Complete the pie chart. So remember that the pie chart is about calculating angles. The sum of the angles should add up to 360. So you should have a column that says angles, and you have the total 60, and the angle should add up to 360. That's what I know. The apple is drawn for you, which means that you should calculate something for the bananas, and then the orange will be the remaining part. Now remember that for this question you will need a protractor or a D, whatever you want to call it, and you will have to draw an exact diagram with correct measurements. If you don't do that, you will not get marks. Okay, complete the pie chart. So I should also technically calculate the angles. It's important to sort of do that as well. Don't just leave that blank. It leaves a bad impression on the examiner. So let's do that for the bananas. So I'm going to say that the bananas were 25 out of 60. And you don't know its angle, so that was theta, and the total angle was 360 degrees. So I can then cross multiply and say that 60 into 360. You can also similarly create ratios and do it whichever way you're comfortable. It's up to you. 6 times 1, 6 times 6. 6 times 25 is 150. So what you're going to do is you're going to place your D like that, and you're going to say that you place your G like that. You start measuring from here, and you say that 150 comes up somewhere here. And what you're going to do it with a pencil, and you're going to mark it like that, and then draw a straight line that goes from there to there. Since I don't have a protractor on the screen, I've drawn it approximately, and I'm going to just mark my angles now. That's 150. I should also calculate the angle for the apple just to show the examiner that I knew what I was doing. So 1/3 is 120, so that's about 120. 150 should be a little, not here, but a little more to the, so that you see a difference between 120 and 150. Okay, so the remaining angle is then 270 minus 360 is approximately 90, so that should be 90, but my diagram's a little skewed. Okay, yeah. Another question on a histogram, it says a group of office workers are each asked to show the distance, kilometers they travel to work. The results for some of their journeys are shown. Again, it's a histogram, so I have frequency density here. There were 20 workers in this category. So this category was 20 workers. So it had a frequency density of 4 and it has a class width of 5. So therefore there were 20 workers. There were 12 workers in the group this 20 to 40. Complete the histogram. So I'm going to say that its frequency density equals to frequency divided by class width. So the frequency was 12, the frequency density was 20. That makes class width was 20, sorry. So the frequency density then should be 0.6. That's a long category with 0.6. So that is where my bar should be. Then it says calculate the percentage of workers who traveled more than 20 kilometers to work. So more than 20 kilometers to work. So those are these people. How many people were there? There were 12, but I don't know the total. So that's what I'm going to have to do. I'm going to have to calculate the other totals so that I can calculate a percentage. That's why this question is 3 marks. So I will have to calculate this frequency density is 1.8. It had a class width of 10. So that's a total of 18 people here. And this one had a frequency density of 6 and a class width of 5. So that's 30 here. So how many people do I have? There were 20 people here. There were 30 people here. There were 12 people here. So 12 and 18 make a total of 30. 30 and 30 is 60. 60 plus 20 is 80. So I had a total of 80 people in this entire survey. How many? What is the percentage I'm looking for? 12 over 80. Why? Because 12 of the workers were between in the 20 to 40 category. That's the highest category that you have. You multiply it with 100. 4 times 2, 4 times 3, 2 times 1, 2 times 5. That gives me 15%. Okay, moving on to the next question quickly. It says a four-sided spinner numbered 1 to 4 is spun many times. The table shows the results. The table shows the results of the spins. The mean of the results is 3. Calculate the value of P. So I don't need frequency density, sorry. Frequency is, mean is basically when you have a frequency table, you must have studied the formula called sum of fx over sum of f. F is the frequency, x is the number that you are observing. Okay, so 6 into 1 plus 5 into 2 plus 13 into 3 plus 4 into p divided by, it says many times, so that's what I'm going to find out. 6 plus 5 plus 13 plus p. And the question is telling you that the mean is equals to 3, so I'm going to equate it to 3. Now I have to be patient with this question. I don't have to rush this through. It's probably 3 marks. So I have about 5 minutes to do this. So I'm going to do this carefully. 39 plus 4p. Why? Because there are some calculations involved. Since you are not allowed a calculator, take your time to do this. 24 plus p equals to 3. It's not wise to make a silly mistake. 45 and 55 plus 4p. 3 times cross multiplied. So 3 times 24 is 72 plus 3p. So 4p minus 3p. Okay, so that's 12 and 5, 17. p equals to 17. So please look at this question to calculate mean from a frequency table. Find the relative frequency of the spinner landing on 2. So that's 5 out of the total. Now I should know the total. Let's find out. It was 24 plus p, so that's 24 plus 17. So that's 5 over 41. That's the relative frequency. Okay. Then write down a prime number. That's not statistics. Let's look at this question. It says 20 students were asked how many pets they own. The responses are shown in the table. Find the median number of pets. So again, the same formula for the median position, half of n plus 1 th. So that's 10.5. Okay, so I'm looking for the 10th observation and the 11th observation. Let's start adding. So 3 observations plus 8. So that makes a total of 11 observations, which means that the 10th and 11th both were in this category. So both were 1, so I'm going to add a 1 plus 1 divided by 2. That also gives me 1. Then when it says mean, I again go back to my formula, sum of fx divided by sum of f. 0 into 3 plus 1 into 8 plus 2 into 3 plus 3 into 4 plus 4 into 0 plus 5 into 2 divided by 20 because there were 20 people. So that's 8. Again, you have 2 marks. Make sure that you add up properly. 8 plus 6 plus 12 plus, that's 0. Okay, interesting. 0 plus 10 over 20. So that's 26, 36 divided by 20. 1.8. Okay, so that's the next question on relative frequency. I want to see if there are some more interesting questions. Yes, they are coming up. Okay, 100 adults were asked the color of their car. The results are shown in the table. Write down the relative frequency that one of these cars is blue. So I'm going to say that blue is basically 23 out of 100. So that's 0.23. Relative frequency is more or less the same as probability. A different group of 1200 adults, and I've changed the total, but it's going to remain in the same proportion. So the relative frequency of one of these adults owning a white car is 0.3. Find the number of adults. So I can say that 0.3 equals to white over 1200. That's what the question is telling you. So white should be 0.3 into 1200, and that should be 360. 3 into 12 is 36, and then I adjust for the number of zeros. So that's 360. Then that's very rare to have a pictogram. This is called a pictogram, where you represent your data with pictures. And that's very rare. So let's see what it says. It says the key that the circle represents 4 people. Okay. Asha asks a group of students about their favorite food. The table and pictogram show some of these results. So 8, it says complete the pictogram. So how many circles would I have to draw? I would have to draw 2 circles. Now, of course, on the exam, you won't draw it with the compass. You just, sort of try to make as accurate a circle as possible. I know that's going to be a bit of trouble for some people, but it's fine. You just need to make sure that you draw 2 circles that are relatively equal size, not different sizes, because it means a different thing. Then banana has 3 circles, which means that there should be 12 here. 4 plus 4 plus 4. Orange has 5. So I need to draw 1 complete circle. And then I need to show 1 more person, which means that I will have to draw a quadrant. Now you can draw whichever quadrant you want, the one on the left, on the right, south, north, whichever one. And so you're going to draw like that. My circle is a bit smaller than it should be. Let me try drawing a little bigger. Okay, so that's 5 people. Then Melon has 4 and I think 3 here, so 7. Okay, that's another question on a histogram. I think we've done enough of histograms for us to be comfortable with this. I'm not going to sort of do this question unless it's something different. It's more or less the same question that we've done before. Let me see if there are any more interesting questions. This is also pretty much the same. The relative, remember that the relative frequency should add up to 1. So 0.15, 0.5, 0.65, and then this should be 0.35. We can also do this. So relative frequency works like probability only. Okay. This is again basically a question on histogram. I don't think there is something very different about it. It's just that they've made it more sort of precise for you. It says find, okay, let's do this first part. Find the value of x in the interval between 30 and x. And they've given you the frequency density. Now remember that the frequency density has the formula frequency divided by class width. And how do you calculate class width? You subtract the upper boundary and the lower boundary. So I'm going to say that 1.6, which is the frequency density, is 32 over 30 minus x. Now, this question all sort of has a sort of a prediction there, but you can just do some maths. You multiply it, although I think it's a sort of more difficult to multiply, but let's try to make it easier for you. So 30 minus x, why am I taking 1.6 to the other side? Because I see a multiple, 16 and 32. So 16 times 1, 16 times 2, so that's 20. So 30 minus x equals to 20. So x should equal 10. That's my final answer. Okay. Then drawing a histogram, I think we need to calculate all the frequency densities. This has a class width of 5, so 15 divided by 5 is 3. This has a class width of 15, so 30 divided by 15 is 2. And then you sort of draw the histogram. I've done enough questions for you on the histogram. So those were the questions from the recent past papers about statistics in paper 1. Remember, anything can come up. You saw that frequency density and is a predominant thing there. There is cumulative frequency. A lot of cumulative frequency actually comes up in paper 2 because sometimes the calculations are more tedious. You have more bigger diagrams and so on, but that is not to say that nothing can come up here. You saw a pie chart coming up, and you also saw pictograms, you saw bar charts, you saw mean calculations, median calculations, mode calculations, and so on. So all of statistics is relevant. Please make sure that you practice before the P1 exam. Thank you.